Hello, my name is Janae Gray. Today we're going to be talking about 1D motion. Motion is described as displacement, time, velocity, and acceleration. The important thing about 1D motion, it means that there is no turning or no going backwards. It's just a forward direction. It can be confusing when you're looking at graphs. So the main points that we're going to be talking about today is position versus time, velocity versus time, and acceleration versus time. On each graph, there should be a title labeling the y and the x-axis. For a position versus time graph, position should be labeled on the y-axis and time should be labeled on the x-axis. So let's get started looking at position versus time graphs. Here, there are 2 points that are highlighted in dark. These show a travel in a positive direction. This next highlighted figure shows a constant motion. So that means there was no increase or no decrease of motion. This highlighted black line shows there is a negative direction. So remember, when there are lines going up, it means they are in a positive direction. When they show no motion, a straight line, it is a constant position. And when it's going down, it is a negative direction. So now let's talk about velocity versus time graph. As you see, the axes are labeled velocity versus time. In this image, you see the highlighted parts. These highlighted parts show that they are decreasing. The 2 yellow lines show that they are decreasing in a negative direction because they are below the 0 line. In orange, it is also decreasing, but it's decreasing in a positive direction. So remember, anything above the 0, it will be in a positive direction, and anything below the 0 will be in a negative direction. This can be confusing sometimes. So make sure you go over it. And these 3 highlighted, they show an increase in direction. As you can see, from 5 to 6, there is an increase in direction in the negative direction, as shown in 14 to 17 seconds and 19 to 20 seconds. They are increasing, but in a negative direction. From 6 to 7 seconds, there is an increase, but in the positive direction. This is because it's above the 0. Now in these 2 highlighted parts, these show constants. So that means there's no increase or no decrease of motion. From 6 to about 12 and a half, and from about 14 to about 18, there is a constant motion. So remember, when there is a slope that is facing downward, it is decreasing. If it is below the 0, that means it's in a negative direction. If the slope is increasing, that means it's going upward. It can be in a negative or positive direction depending on if it's above or below the 0. If there is not an increase or decrease or no movement at all, there are constant motions, which we've seen earlier. So now we have went over position versus time, velocity versus time. So now let's go over acceleration versus time. In this acceleration versus time graph, you see that there's a title. The X and Y are labeled. In the highlighted portion of this graph, from 2 to 4, and from 6 to 7, it shows a 0 acceleration. That means there were no acceleration at this time. And these two highlighted parts, from 0 to 2, that shows that there was a constant acceleration in the positive direction. In 4 seconds to 6 seconds, there is a constant acceleration, but it's in a negative direction. So remember that there is always a constant when there is no movements that are increasing or decreasing. And there's a 0 acceleration when it's on the 0. And there's positive above the axis of 0 and negative below the axis of 0. So why does this matter, you're asking me? Well, the importance of these three graphs is that they correlate with each other. The slope of the position graph as a function of time is equal to the velocity at that time. And the slope of the velocity graph at a function of time is equal to the acceleration. So you use the position graph to find the velocity. So if you wanted to find the average velocity of a certain time period, you would choose a position from, like, as example, 1 to 10, and you choose their time. You subtract the final minus the initial of the time and of the distance, and you will find your average velocity. The same thing that goes with acceleration. You will look at a velocity graph as the slope. If you choose 2 points on the velocity graph and you subtract them and divide them by their final minus their initial time, you can find the average acceleration. So, as you can see from these graphs, position, velocity, and acceleration help each other. It's easy to find the area of each one by calculating the area up under the graphs. When the position is going in a positive direction, it means that the velocity is increasing, which makes the acceleration constant. This might sound complicated, but after a few tries and practices, you will be able to get it right. I hope this video was helpful, and have a great day.